In this lesson we're going to look at how to use the addition formula to prove some complicated trigonometric identities. So to start with here, the main thing to remember is these two trig identities from earlier on in fourth year. Sine squared alpha plus cos squared alpha equals 1, and also tan alpha equals sine alpha over cos alpha. We also have to remember that the top formula here can be rearranged to sine squared alpha equals 1 minus cos squared alpha, and also cos squared alpha is equal to 1 minus sine squared alpha. So let's look at the first example here. Prove that cos of 90 minus x is equal to sine x. The best way to do these examples is to take the left hand side and try and use your trig identities to prove that this equals the right hand side. So if we start with the left hand side and we start saying that cos of 90 minus x is the same as cos of 90 cos of x plus sine of 90 sine of x using your addition formula. Then we look to see if we can do anything else to it, and we can see that the cos of 90, we should be able to know what that is. Now that's 0 from the graph, so we've got 0 times cos x plus, and also sine of 90 we should know is 1 from the graph. So this goes to 0 and this goes to sine x, so we have sine x here, and that equals the right hand side, and that's us proving what we set out to do. Okay, a wee bit more complicated here. We've got to prove that this here is equal to tan x plus tan y. So we'll start again with the left hand side, and we look to see what we can do. Now sin x plus y, you can use your addition formula to expand that to sin x cos y plus cos x sin y. So let's do that. And then what we can do next is we can split this into two separate fractions. At the end of the day we're looking for something plus something else. We don't want it all over anything, so separate it into two different fractions. Sin x cos y over cos x cos y plus cos x sin y over cos x cos y. Now at this point you should see that you can divide top and bottom by the same thing here. So in this fraction we can divide top and bottom by cos y, and on this side we can divide top and bottom by cos x. So what that does is it leaves us with sine over cos, and then sin y over cos y. This is the point where you need to remember this, that tan alpha is equal to sine over cos. So this is the same as tan x, and this is the same as tan y, which is the same as the right hand side.